Welcome to the Unit 11 Section 5 video on the quadratic formula. You have learned several methods for solving quadratic equations. We have been solving by graphing, factoring, using square roots, and completing the square. Another method is to use the quadratic formula, which allows you to solve any quadratic equation in standard form. By completing the square on the standard form of the quadratic equation, you can determine the quadratic formula. So let's go through the derivation of a quadratic formula so you can see that it comes from somewhere. So let's start off with the quadratic equation in standard form. We are going to solve this quadratic equation for x. So let's start by dividing both sides by a. Okay, so we are going to divide everything by a to get x squared with no coefficient other than 1. So that gives us b over a x, and c over a is our constant term. Now we are going to subtract c over a from both sides. Now we are going to complete the square. And remember, to complete the square, we take our b term, which is b over a, divide it by 2, which gives us b over 2a, and then we square it, which is going to give us b over 2a squared to add to each side. Now, let's factor and simplify. Since we have a perfect square trinomial on the left side, we can take the square root of the first, which is x, the square root of the last, which is b over 2a, the sign of the middle term in between, and square it. So that's where x plus b over 2a quantity squared comes from on the left. On the right side, we're going to simplify a little bit. Let's move the order of our terms, and let's square everything that's inside of our parentheses. So that gives us b squared over 4a squared minus c over a. Now, let's use common denominators on the right side. So nothing has changed on the left. We are going to multiply c over a by 4a over 4a. So we're going to multiply it essentially by 1 so that we can get a common denominator. And then we will simplify that right side into one fraction, b squared minus 4ac all over 4a squared. Now that we have simplified the right side, let's take the square roots of each side. So the square root of the left-hand side is quite obviously x plus b over 2a. On the right side, we are going to get plus or minus the square root of our numerator, b squared minus 4ac, all over 2a, because the square root of 4 is 2, and the square root of a squared is a. Now, let's finally subtract b over 2a from each side to get x by itself. So we're going to stick that out in front. So you have minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And then finally, since we have a common denominator of 2a, we can combine to get the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So our quadratic formula gives us the solutions of a quadratic equation of the form ax squared plus bx plus c equals 0, where a does not equal 0, by using the formula x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. To find the zeros of a quadratic equation in standard form, simply plug the values for a, b, and c into the quadratic formula. Note that some problems may need to first be arranged into standard form. So the quadratic formula, as complicated as it looks, is quite easy to use, because all you have to do is take your standard form quadratic that is set equal to 0, identify a, b, and c, and then simply plug those values into the quadratic formula. So here we have 4 is A, 3 is B, and negative 85 is C. So we just simply plug those values into the quadratic formula, and then from there we're going to simplify, starting with the square root. So if you do everything under the square root, 3 squared minus 4 times negative 85, that's going to give you 1369. Then we can simplify that. As it turns out, that is a perfect square. Square root of 1369 is 37. Then we can combine our numerators by doing plus for one solution and minus for the other, and we'll end up with the solutions negative 5 and 17 over 4. For this example, we identify our A, B, and C, plug them into the quadratic formula, and then simplify, starting with the square root, which gives us the square root of 145. The minus a negative 5 gives us positive 5 out in the front. 2 times 3 in the denominator gives us 6. And so our two solutions here, since we cannot simplify the square root of 145, are 5 plus the square root of 145 over 6 and 5 minus the square root of 145 over 6. Now, if you just want to leave your solution written as 5 plus or minus the square root of 145 over 6, that is perfectly fine. I just wanted to show you that plus or minus does give us two solutions here. For this example, we need to first get standard form equal to 0 by subtracting 17 from each side. Once we do that, we can plug our values into the quadratic formula and then start simplifying. We have negative 3 plus or minus the square root of 648 over 18. And that's going to simplify us down to negative 1/3 plus or minus the square root of 2. For D, we have to first move the 8x, negative 8x, and the positive 4x squared over to the other side, get our standard form, and then we're going to plug into the quadratic formula. Now when we do that, we're going to end up with the square root of 0. Of course, 10 plus 0 is the same thing as 10 minus 0, so that just leaves us with 10 halves, which is 5. So here we have one solution. If a quadratic equation is in standard form, the discriminant of a quadratic equation is b squared minus 4ac, which is the part of the equation under the radical sign. The discriminant can tell you how many solutions a quadratic equation will have. So if b squared minus 4ac is greater than 0, the equation has two real solutions, because what is underneath the square root is positive. You're going to have plus that piece and minus that piece, giving you two solutions. If b squared minus 4ac is equal to 0, as we previously saw, the equation has one solution because plus 0 and minus 0 give you the same thing. If b squared minus 4ac is less than 0, the equation has no real solutions because you cannot take the square root of a negative number and get a real solution. So we're going to use the discriminant of each quadratic equation to find out the number of solutions. And the discriminant is not a bad thing to look at first, because if you can determine that the equation has no real solutions, then that would be your answer. You would not need to go through the entire quadratic formula to state that as your solution. So for this first example, first you need to get it set equal to 0. And then we are going to plug in our A and our B and our C into the discriminant. Once we evaluate it, we get 64, which is positive, which tells us that we have two real solutions. For this one, get everything on one side and set it equal to 0. Plug in your A, B, and C, and we find that we have negative 96, which tells us we have no real solutions. For this example, again, move everything to one side, plug in your A, B, and C, C in this case would be 0 since there's no constant term. And we get 81, which has two real solutions since it's positive. For this one, subtract 8x from each side, plug in your -4, -8, and -4 for A, B, and C, and we get 0, which tells us we have one real solution. For E, add 3 to each side to get us a standard form equation set equal to 0. Plug in your A, B, and C, solve it to get -220, which tells us no real solution since our discriminant is negative. And for this last one, we have -x² plus 4x minus 1 equals 3. Subtract 3 from each side, plug in your A, B, and C to get 0, which tells us that we have one real solution. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.